Hello everyone. Welcome to the live broadcast, and thank you so much for joining us today. I'm really excited about today's sessions because we are diving into very exciting and transformative topic on AI and how AI is shaping the future of progress tracking and schedule performance, specifically in the construction industry. I know there are a lot of buzz around AI, but my guest speaker today has been implementing this and in this solution for other companies. So, what we are about to share with you is really practical, what's available out there, and how you can really have progressing and schedule performance in real time and enhance that. And especially in construction, as you know, managing large scale construction projects comes with complex challenges, and really staying on top of the progress tracking and scheduling is really key in delivering our projects on time and on budget. And that's where AI can come in and help us in transforming the way that we track progress and optimize the schedule in real time. And that's what today's session is all about. We are about to explore how these advanced technologies are really driving efficiency and innovation across different industries such as healthcare, data centers, oil and gas, manufacturing, and these type of industries. But what we are about to cover can be applied to other industries as well. And you're going to hear about AI powered solutions that are really transforming project controls. They're actually in there, and you can tap into these solutions out there and helping you make faster decisions and data driven decisions to mitigate risk effectively and especially in real time. Sounds exciting, isn't it? I hope you're excited as much as I am, especially with the specific guest speaker and the company we are about to bring here. I have a great history. 5 or 6 years ago, I got to see their fantastic work through a video where there were a little robot going up the stairs in the construction, scanning the whole construction and site and progress, measure the progress in real time, and it was updated all over the schedule and everywhere. It was really impressive. And at that time, I didn't know much about this company, but I used that video in part of my keynote speech. And now we have a representative from that company coming here, sharing exactly not 5 years ago from what I saw and where we are now with the state of AI in construction and progress tracking and where the industry is heading. So you are here for a great treat, and we are going to have great discussions today. So if you are here, please go ahead in the chat, introduce yourself, tell us who you are, from which country you are tuning in, and what you would like to learn by the end of this 1 hour casual conversation we have on this fantastic topic of AI in progress tracking and schedule performance. And about me, I am Shora Gorbani, the founder and technical director of Project Control Academy, which is the leading global provider of comprehensive and online training programs in project controls. And today, really, I'm very excited about our guest speaker. Let me introduce our guest speaker today. He is the head of solution engineering and channel partnership at Doxel, and that's the company I was talking about. Doxel is a pioneer in AI powered construction progress tracking. And about our speaker, he has been at the forefront of developing AI powered solutions that address the challenges of large and complex projects. So please help me give a big warm welcome to Shankar Bellam to join this virtual stage and tell us what he has in store for us. Welcome, Shankar, and thank you so much for joining us. And I cannot wait to learn more from you on this exciting topic.
Thank you so much for inviting me here. It's a real pleasure to be here and honored to talk to everyone.
Thank you, Shankar. So, would you mind, like, to get started? I had a very brief introduction of you. Tell us a bit more about yourself and how you got involved in AI and developing AI-based solution for other companies. Can you share a bit more about yourself, please?
Sure thing. I have been in the construction space for a little over a decade and a half now, and I started working in the commercial space, going across the Houston city, building commercial projects all the way north in Woodlands and all the way south in Galveston. And one of my core objectives back then was to measure construction progress and use that to analyze, is the project on track? What is the delay for schedule that's going to be delayed? And what are the steps we need to take to bring it back on track? So, although the core objective was to analyze progress, but a lot of time was spent in driving to the sites, measuring progress, marking it in two-dimensional plans on what are the stages of construction, and then coming back to the office and spending the time left to analyze the information and come up with mitigation steps to avoid a potential delay. So that definitely had an impression on my mind on how much time is spent on just measuring and how little time is left for analyzing it and making decisions to truly bring about a change in the deliverable of the project. And I was fortunate to be in a state where I worked in technology space, and when I heard about Doxel and the amazing technology that they have developed using computer vision and AI to automate the process of progress tracking so that I don't have to be counting beans on the site anymore. As project engineers, product managers, superintendents, we can spend more time using the information on progress to to basically make decisions on how to mitigate the delays that are being forecasted, how to get more labor that we need to do any recovery on the project, and how to ensure safety and quality on the project. So more time is freed up to spend on more valuable tasks on the project. So that's how I came about in this space, and I'm absolutely fortunate to be working with Doxel and helping clients and customers leverage and use AI to automatically measure progress on their projects.
How exciting. Thank you so much, Shankar. Cannot wait to learn more from you in this session. And a big shout out to all who have been joining us today from all across the globe. I see you, Alberto, joining us from Venezuela. Welcome on board. I see Hirimena joining us from, I think, Canada. And he's looking to learn more about AI in project tracking. So if you are here, I see a lot of you are live. So please go ahead and introduce yourself in the chat. And also may ask for a quick favor, if you don't mind, click on share or reshare, repost, so others in your network can also join the conversation and benefit from this insightful session we have, forward-looking, exciting topic we are about to explore. So please go ahead and repost this before we move on to the rest of this session. Oh, see who is here, Dr. Demetrius and Antonius. So from UK joining us. Thank you so much for joining, Dr. Demetrius. It's been a while, so glad to see you here. I also see Karen joining us from Paris. Thank you so much for joining us, Karen. So I see you now. You're introducing yourself. Jason is joining us from right here, Katy, Texas. So thanks for joining us. So here again, regarding today's topic is about how AI is shaping the future of progress tracking and scheduled performance. So to get started, Shankar, I want you to, for all of us to be on the same page, please can you tell us first what AI is, so all of us know exactly what we mean by AI, and also how AI-powered solutions really differ from the traditional methods, and what specific benefits do they bring to the table, especially on construction projects that's really hard to measure progress on. I know construction is one of the industries that's really hard to tap on and usually behind. So I'm very glad we have this discussion on AI in construction. So can you first open up the topic of AI and the benefits of AI as compared to the traditional methods?
Sure thing. I think AI has definitely become mainstream with ChatGPT, where everyone has heard AI and everyone wants to see how it can help them in their jobs, how it can make life easier for them. But traditionally speaking, AI, artificial intelligence, is basically a stream where you leverage technology. It could be a combination of machine learning, deep learning to automate manual redundant tasks. And there's using data science, we are able to leverage computer vision to extract information from the images automatically and make sense out of it. There's different kinds of AI, supervised learning, unsupervised learning, but the core concept boils down to leveraging technology to automate extraction of information from data, whether that be vision based data, that be data analytics aspect of it. And in the construction space, we are primarily talking about using AI on the images that are collected from the construction site to extract information on what is the progress, and use that information to map against your plan, whether it be in the form of a schedule, Primavera P6 schedule, or schedule of values for your budget tracking, so that you can see what is your uh, both schedule performance as well as cost performance. And historically speaking, construction projects have relied on manual data collection, which is, we all know, is relatively slow, it's inconsistent, and it's prone to errors. I have done that back in the day when I used to walk the sites and manually collect what's the progress that I see visually with my eyes. And we see that the projects are becoming larger in scale, more complex in nature. So we definitely see technologies evolve, specifically using computer vision technology that automates the data collection aspect of it. And what it does is it enables the teams to visually track progress and analyze the performance with precision. And this automation means that decisions are no longer based on outdated or subjective reports, but they're based on accurate, objective data that are driving projects forward more efficiently and with less risk.
Great. Thank you so much for opening that topic for us, Shankar. So, another question I have for you is again talking about AI. Can you walk us through how data is captured and how AI translate that data into actionable insights, especially when we are talking about progress tracking and schedule performance? How is really been done?
Sure thing. Let me actually share a small video that can show you how it works, and I'll talk through it while it plays. Are you able to see the video play out?
Just give me a second. Yes, we do.
Okay.
Perfect.
So
Thank
what
you.
you see here is a person wearing a small hard hat based 360-degree video camera. So this person is just walking the site completely hands-free operation, and the core objective here is to capture 360-degree video of the entire construction site wherever you see construction happening. And when this video is processed by computer vision, it's trying to detect geometries, shapes, basically as the 3D model stays. The 3D model tells the software spatially where the systems or components are planned to be installed. And computer vision is used to detect those geometries. And because the model tells the AI software this rectangular duct that you see is a rectangular duct, the conduits, it is able to extract the information. And the next step is going to be from that data, you are identifying, okay, what zone is it in, what floor is it in, and it is calculating percent complete. So it is basically talking about, it is extracting information on how much quantities of ductwork has been installed, right? Number one. And it is identifying visually what stage of construction is it in. So it is using computer vision. The computer vision algorithms have been trained to visually look at any system or trade, let's say a mechanical duct, and identify if the duct is insulated or is it not insulated, if the duct is hung or is it still in the supports and hanger stage. So the use of computer vision very similar to the Tesla cars. When the Tesla cars are driving down the road, they're able to look at a stop sign and identify by the shape of the sign, by the color and the letters, that this is a stop sign and what is the action expected. Or there are pedestrians walking on the road or the car is moving. Similar technology using vision, Doxel's AI is able to identify what components have been installed, how much quantities have been installed, what stage of construction is it in. So that is how a 360-degree video from the site is translated into construction progress in the form of quantities installed and stages of construction. And those are converted into visual progress reports and mapped to the schedule to identify how is it from a plan versus actual standpoint, mapped to an SOV to see how is the cost performance going on as well.
That's really impressive, Shankar. Wow. So the one that was on the head of that construction worker was capturing and taking all of that, right?
Right.
So, and how, so there, I assume the progress is in real time, right? So, but someone needs to walk the site to be able to capture that progress. And would it automatically update the schedule or update the tracking, progress tracking? Can you also walk us on the project control side of the things, how that works, if you don't mind? Is it actually in real time or um, where we are on that?
Sure. It's I would say is near real time. So what happens is today to make it work with the existing workflow, we have made the data capture process enabled offline because not all construction sites have internet and Wi-Fi available. So the person walking the site is just capturing the video. When the person comes back to the job site trailer or office where they have internet available, they upload the video using a simple iPhone app. They just click on upload and the iPhone app connects with the camera and automatically uploads the video for processing using Doxel's AI. And this video is processed and is comparing the site imagery against a 3D model and is extracting the quantities installed, stages of construction. And this entire process takes like hours, right? In 4 or 5 hours the images are processed. The following day you have all the dashboards up to date as well.
Okay, great. So it's not truly real time, but it just really helped a lot in progressing and capturing the tracking and to track the progress, right, Shankar? So
That is right. Yeah. So typically, what we see is we recommend at least once a week data capture. And in some of the projects, we have seen it is truly driven by what is the frequency of planning updates. You see that typically the superintendents from the general contractors have a weekly meeting with the subcontractors. So we try to identify, okay, if you're meeting on the Monday or the Tuesday of the week, then the data capture is scheduled to be on the end of the week on Friday or Saturday so that you have the latest fresh data being used for those meetings and coordination aspect of it. In some projects, we see this happen almost every 2 days or every day. So the data capture frequency is driven by how what is the pace of construction, how fast is the construction going on, and how much more frequency do we need to help the data stay fresh in those decisions made on the field.
and may I ask, how does it know? Like, are you giving the plant layouts and everything to that AI-powered solution? So at Doxel, so that it figures out the progress? Like, what is the basis? How does it know? Sorry, maybe that's a silly question, but how does it know? And is it just for the completed building, or that you are doing the final things in? Or let's say if you are just building, you just mentioned also in oil and gas, we are building an oil and gas refinery, which is not really everything, in a condensed place. So how would it know exactly the progress, or is it dependent on how you're setting up the system? I'm just curious to learn more on really how it knows about the progress and really just as it scans it, it just captures the data.
Sure thing. So the key information that is extracted from the 360-degree video is how much quantities have been installed, which is basically even our iPhones can measure distance between 2 points. So we use similar technology to quantify the quantities installed on site. The stages of construction for mechanical duct, let's say it is the pipe supports and hangers installed, is the pipe is the duct work hung, is the duct insulated, or let's say if you're talking about pipe racks in an oil and gas field, have the pipe racks supports and hangers been installed, has the pipe been hung, is the pipe insulated. So it is identifying those stages of construction using computer vision, and all that information is basically becoming the foundational blocks of information extracted from the video. Quantities installed, stages of construction. When you map those and use rules of credit and roll up into percent complete by trade and use that information to update your schedule to understand what is the plan versus actual, then that gives you a true picture of what progress is. So when you talk about progress, any person on the field would talk about in the terms of quantities installed and percent complete, and that is what Doxel is extracting from the video as well.
So you don't need to load the 3D model or anything to that equipment to be able to understand the progress. It just figures that out by itself, right?
So if you can share the video that I'm just about to share here,
Yes, here you go.
I can quickly walk through that. So the 3D model is the prerequisite for the software to work. So the two key inputs are the video that is captured from the side, that as you can see here on the screen, a person walking and capturing the 360-degree video, and the 3D model. The
Mm.
3D model tells the software spatially where the systems and components are planned to be installed, and the software is overlaying the 3D model with the images collected from the site, and it is identifying the quantities installed, and it is creating an overall matrix, a network effect of identifying each and every task, what stage they are in, and how does the progress roll up. And and then the visual reports that are created are backed by photo evidence. So you can see that the 3D model and the photo side by side, you can visually verify the installation, and the quantities and the stages of construction are translated into these 3D progress reports and a very detailed quantities report that you can slice and dice by stage, by trade, by system, by zone, by areas, however you need to be able to understand what is the true state of progress.
Wow, that's quite impressive. Thank you very much for sharing that. So when you upload the video, then somebody needs to translate that progress into the schedule, or that can be also done automatically.
So that's the huge differentiation of using AI based technologies. So Doxel's AI is automatically using VSLAM, figuring out what was the path that was taken by the person during data capture. And then it is basically overlaying that with the 3D model, and it is using the spatial information on the model to identify where to look in the video for the components, and it is automatically identifying if the component got installed, what are the quantities, what are the stages of construction. And like any AI technology in the world, all AI algorithms have a threshold of confidence. Every time the AI is providing you a decision, hey, I see a component, I see here is the quantities or here is the stage of construction, it always gives that information with a certain threshold of confidence. And we in Doxel have set the threshold in such a way that if the AI is not confident, is less than 95% confident on the information it is or the decision that is making on, then it gets kicked into a QA/QC's queue so that the person can give it thumbs up or thumbs down. They're essentially, we call it supervised learning, where the human is giving reinforcement learning if the decision was good or if the decision was bad. This basically trains the AI algorithm to continuously make right decisions and is training on the decisions that are made bad as well. So that is how the overall data processing pipeline is done automatically. And we have a supervised learning aspect where a human QA/QC is improving, helping improve the accuracy aspect of it. And as we all know, accuracy and reliability of insights delivered to the field team make a huge impact on user adoption. Everyone on the field is rightfully skeptical of what AI technology is throwing at them in the form of insights and data. And Doxel's prime and core mission is to become a decision fabric of the construction industry. And to be able to do that, we have to provide consistently reliable, accurate, objective data for all the stakeholders on the field, from the superintendents to the board, product executives, and vice presidents. And to make sure that when AI is used for automating the data processing pipeline and making it faster and more frequent and objective, we are using the human QA aspect of it to make sure that the accuracy stays to a level where it is always reliable for the folks to make decisions on the projects.
You answered my next question, Shankar. Yeah, actually, whenever we are talking about AI, the next question is the confidence level and the accuracy, how reliable those data is. So based on my understanding is you let the machine do its work and to do things faster, but there would be a human doing the QA part for two reasons: to make sure that's accurate, and second, for the learning process of the AI so that it improves itself better moving forward. So that's right, right? So it's just perfect. The other
Absolutely.
We have a great question by Emmanuel that I'm going to show on the screen. Emmanuel is asking, how would you detect the cable termination? Cable of pulling can be clearly seen, but things like termination, which is physically small but can be time consuming, is that also possible through that AI machine?
So we have seen three aspects of this. Uh, when you see bundles of cables in the cable trays, those are visible, like you said, Emmanuel. We will be able to track those as bundles. Um, and if the cables are being pulled through conduits, it is not visible. So Doxel is not able to validate that information that the cables got pulled through those conduits. And the third aspect is, did the cables terminate in the panels? So we have had a really large distribution and warehouse facility where cable pulling and cable termination was a validation step that was required to be done by the field engineer every single week. And because of such a large site, it was very time consuming and labor intensive. So in that case, although Dossel was not able to validate if the cables were pulled through the conduits, we asked the teams to keep the panels open, and as a workaround, we were able to identify if the cables got terminated at the panels. And this was used as an inference to say that if the cables got terminated, it means that the cables got pulled as well. So there are certain use cases where it is achieved through workaround processes, but yes, it depends on whether the cables are visible or not.
Fantastic. I hope it answers your question, Emmanuel. And please, as we go on, have your questions coming so you can benefit the most from this session. Great question, Emmanuel. So, just I'm curious, Shankar, you mentioned about okay, AI progressing and then the human factor, human element also double checking and making sure everything is working. So I want to know what are really challenges when it comes to progress measurement and scheduled performance, especially in the construction industry. As I mentioned earlier, in construction is a bit of monster as compared to other industries. So, what challenges you have faced, and what made you really to come up with this solution? And if you can also walk us through an application of a project that you really applied this and the impact of that. Sorry, I'm asking so many questions in one. I'm just curious to learn more from you, Shankar.
Sure thing. I think we can break that down into a couple of questions, right? The first thing is, what are the biggest inefficiencies that we see in the construction today, and how does Doxel address them? So one of the major inefficiency is the lack of accurate and timely data on how projects are progressing, because that's the number one decision point, or the data input that goes into making decisions, which is what's the progress on the project. Yeah, because typically you see that these leads to schedule overruns and increased costs. So Doxel solves this by providing production rate data. It gives the team visibility into how fast are the activities being completed. And with this information, the project leaders can adjust manpower, material, and sequencing on the fly, and they are able to optimize resources and accelerate the timelines. For example, DPR Construction uses Doxel's production rate data to benchmark projects and win jobs by confidently proposing faster schedules with less risk. So, just by having accurate and timely data, DPR was able to achieve that on their projects. And the second aspect is, how does it differ from traditional project management tools? So traditional project management tools rely on manual inputs, right? And they're often siloed. They create information gaps and misalignment between teams. Doxel automatically captures and analyzes field data, and it provides a comprehensive view of the project progress, and which is accessible to everyone from the field teams to executors. So this shared understanding, it sort of fosters a better communication and collaboration, and it aligns all the stakeholders around a single source of truth, which is what is the progress on the field, how much quantities have been installed, what does that translate to percent complete. And when you see exactly what's happening on the site, there's no room for misinterpretation or second guessing. So that truly drives projects to work in a collaborative manner from the owners, construction managers, general contractors, subcontractors, all the stakeholders on the project working towards a common goal of delivering the project on time, under budget.
Sorry, I was muted. Thank you so much for explaining that, Shankar. I really appreciate that. How about the application of Doxel in a real project? Can you walk us through the benefits and what benefits you have seen by really doing that in a real construction project? If you can walk us through an example, we want to see how it really worked and the benefits gained for
Sure.
utilizing the solution.
Sure. So we can extend the example that I mentioned where production rate was being used to win jobs. So DPI Construction, as I mentioned, it they use Doxel's production rate data to benchmark their projects, and they're identifying areas for improvement. So when you use Doxel to track construction, you're essentially standardizing the way that you measure progress by trades, by systems. And because you have accurate historical data on how long activities take and how efficiently were they completed, DPR was able to bid on new projects with confidence, with accelerated schedules, and they were able to propose these faster schedules and demonstrate lower risk to the owners because it was backed by data on what they were able to deliver in the past. So, this competitive edge has helped them win jobs by promising and delivering more predictable outcomes. So, that is an example of how using accurate, consistent, repeatable progress tracking using automated solutions like Doxel across your projects can help you win more jobs as well.
That's amazing. Thank you so much for shedding more light on that. And talking about this, we have a good question. I'm going to highlight that here. Gail is asking for DPR. Do they tie the progress to cost and track earned value as well? Because, yeah, especially for earned value, one of the main and key inputs is the physical progress. So, how do you tie that to the cost and earned value as well? Is it done in real time or near real time and automatic, or how would it work on that side as well?
In certain projects, yes, customers do tie the quantities being tracked by Doxel from the video to their schedule of values so that they are able to see the quantities that are actually installed on the field, quantities that are claimed in the invoices for pay application validations purposes as well. So this is in essence providing you the earned value aspect of tracking the projects and is able to help you identify and track what is the cost performance of the products as well.
Perfect. Thank you so much, Shankar. So, going back to our earlier conversation that you had about the example that you brought and the application of AI in construction, and I like the benchmarking aspect. I didn't think about that to be able to develop more accurate schedules and bid on projects as well. So, talking about that, I'm curious to know how do you embed Doxel into your existing project management tools? Do you need to kind of revamp the whole structure, or is it kind of an easy and smooth integration that you can have? Can you tell us a bit more about that part? Let's say we have our Primavera schedule, we have our earned value tool, we have this tool, that tool. How do you incorporate this AI-based Doxel tool into our existing tools to be able to gain those benefits that you mentioned?
Sure thing. And that definitely is one of the key decision factors for anyone to choose an AI solution, a solution that is conforming to the existing workflows and is not disrupting the project management processes and systems that you have put in place. So, from a Doxel standpoint, people are already walking the site and they're already used to capturing 360-degree videos or images for historical documentation purposes. Doxel is extending that by mining information from the videos and images collected to extract quantities and progress information. So there's no disruption in the data capture process. It's the very same process that people are already used to on the field. The the process of extracting information from the video and mapping to the BIM and schedule is again seamless. So the onboarding process is typically 2 to 3 weeks, where we take the 3D model provided by the customers, we take the Primavera P6 or Microsoft project schedules provided by the customers, and we map them together. So the expectation is not for the customers to make any changes to your BIM or your schedule. Our onboarding team takes care of doing that using a semi-automated process. So we have built-in tools and processes that allows us to onboard. Doesn't matter how big your project is, from 200,000 square feet to a 2 million square feet facilities, it can be onboarded within 2 to 3 weeks at a very fast pace. So the objective has been for our product teams and operations team to build tooling in such a way that we are not expecting the scheduling teams, the product control teams to make any changes to the schedule. We're not expecting any changes to be made to the billing information model as well. You just provide us the files as is, and our onboarding team takes care of mapping that together. And finally, on the reporting aspect of it, when the information is extracted, it's the progress reports. Every team on the field is used to seeing progress reports. We actually have pre-configured trades, more than 15 plus trades, 90 plus stages of construction, but we provide the flexibility of configuring those. So, for example, if on a project you have two separate trades installing mechanical in two different zones, so then we can split it into those two separate places as well. And even the stages of construction for any system that we track, they're pre-configured. Doxel has tracked more than 900 million square feet of construction projects across industries, so they are all pre-configured stages. But if we need to change those, add those, because they are tracked differently in different regions and different projects, then those are configurable as well. And the entire data architecture is flexible data architecture, which means it allows us to create tailored, customized reporting A3 reports for owners. Let's say the general contractor is required to put together a summary report, a scheduled summary executive report for the owners, then we can put that together as well. So the overall aspect of data, how the data is captured, how the data is processed, how the reports are presented, a core philosophy that our product teams use in making decisions is make the UI and UX intuitive, seamless, and fit into the existing workflow that the customers have, so that it doesn't cause so that it causes minimum disruption as much as possible.
That's amazing. So the customer is not going to be left alone. You are there to assist to create that integration. And is it just one time on the onboarding? So when you create that mapping, that's it, right? So after that, everything would be seamlessly done, or every time for every update, you also need to interfere and help and assist those who are using the software.
We all know that the moment construction starts, everything changes. Schedule changes every week, the design
Exactly.
changes every other week. So we have built in a process and system in such a way that any changes that happen to your schedule or the BIM, we make sure that the latest design files, the latest schedule files are ingested to keep the reference schedule and model up to date on the Doxels end. And we have a construction client manager with decades of years of experience in the construction industry assigned, designated to the projects, so that they make sure that all the files are up to date on DoxelSend that are being used to compare the video against, and any user management, change management, the training aspect of it, making sure that the stakeholders, all the way from subcontractors, general contractor, construction managers, owners, all the stakeholders are able to derive value and use Doxel to make decisions. So we do have a construction plan manager who is assigned to the projects, and that's their core goal and objective as well.
Wow, that's amazing. So to have the full support throughout the project lifecycle, basically, right?
100%.
Uh, that's great. So we talked a lot about construction. So can you just apply AI-based Doxel tool for progress tracking only in the construction industry, Shankar, or you have developed that for other industries as well?
So the primary industries that Doxel is used is healthcare space, data centers, life science, advanced manufacturing, EV manufacturing, battery manufacturing, oil and gas projects. So pretty much any large and complex construction project where tracking progress automatically, consistently, every single week, objectively, is going to help them build facilities faster, is going to help them manage cash outflows more efficiently and effectively, is a good use case for Doxel.
Perfect. Thank you very much, Shankar. So now we talked so much about Doxel, but are there any other AI based tools out there that can help you track progress? Or do you have any advice for the listeners on what criteria they need to look into when they want to choose the right AI powered tool for progress tracking or for any other project control aspect of the project?
Sure thing. I'm definitely biased, but Doxel has been in the forefront of progress tracking. But there are many players in the space. Some of the core things that truly make a difference when you're choosing an AI solution is the three pillars: how easy and seamless is the data capture process, how automated is the data processing aspect of it, so that it's scalable, right? So you want a solution that is scalable. If you have multiple projects across the nation, across the globe, you want to make sure that you're able to scale the solution, and how seamlessly the outputs and the insights integrate within your workflow. And when it comes to choosing the technology itself, you want to focus on making sure that what are the real world, like, is the solution using real world quantities in the form of linear feet and square feet extracted from the videos, or is it counting how many BIM components do you have installed, right? So you want to make sure that the solution is using the real world quantities to come up with a percent complete. You want a solution that is comprehensive. It is tracking across all the trades, all the stages that are visible, so that there is no blind spots or there's no gaps, because you want to have a solution that is reliable for decision making. And if it is comprehensive and is providing progress across all the trades, all the stages, then it is giving you a more accurate and a comprehensive picture on your progress aspect as well. And if you have more stages of construction being tracked, then you're able to get more proactive insights into any potential production slips that you might have. And you also want a solution that is easy to deploy, faster to deploy. You don't want a solution that requires you to deploy resources to go ahead and onboard a model or make changes to your schedule or have someone capture using any specialized equipment. You want something that is simple to capture using off the shelf cameras. You want a solution that is scalable in the form of not having to make any changes or not asking your general contractors to make a lot of changes to their BIM or schedule files. And more importantly, you want a solution that can get up and running within a couple of weeks. You don't want to be having a long 3, 4, 5 months long onboarding process, so that you are seeing faster time to value. Because if you're able to get to value faster, you're able to validate the value, you're able to expand to more products as well. So overall, there are various criteria, but you would want to look at easier, simpler, faster data capture using off the shelf hardware. You want to see data processing that is using real world quantities, is using rules of credit, so that the percent completes that you see is reliable and is meaningful for the field teams to make decisions on, and a solution that is faster time to value, faster to deploy on. And you want to have some kind of flexible data architecture so that you can make tailored custom reports that you need on your side to make decisions as well.
Fantastic. Great advice. Thank you so much, Shankar. Now, maybe again, I haven't seen questions. If you have anyone have question, please have them come in. So I'm curious to know where are we with the state of AI in construction or in managing projects at the moment? I know Doxel has been really ahead of the curve, no doubt. When I got across Doxel 5, 6 years ago, I think the things we were doing, nobody else has any idea about AI or what you were doing back then. Now it's just AI. Everybody's talking about that. We are all using ChatGPT. We are all seeing the power of AI. But 5, 6 years ago, I think you were the pioneer in that. So, where are you now, if you don't mind, on the AI, and where do you see the industry at the moment in the application of AI in managing the projects? Where are we now? Before I ask you about the future, where are we now? Because we talk a lot about it, but are we there yet? Not talking just about Doxel, I know you guys are there, but in the industry general.
Sure, sure. So we can definitely talk about what's the future of construction technology, and I can talk about where we are as Doxel and how it is positioned to lead that change. I think the future of construction technology lies in leveraging real-time data to make better decisions faster, right? So it's all about how fast we can make the decisions, because we are seeing data centers being built, used to be built in 3 years time frame, 2 years time frame. Now they're talking about 18 months, 12 months to build. So although the construction products are becoming more complex, larger in scale, but we are seeing more use cases of accelerated schedules where the general contractors are pushing the envelope on optimizing construction deliverability, making it more predictable at the same time as well. So, having the ability to track every activity and use the data to inform decisions is critical, especially in those large, complex, accelerated schedules. And Doxel's AI powered platform is at the forefront of this change. By providing accurate, real time data, we are helping the industry shift from a reactive to a proactive product management space. And we're not just tracking progress, we are really enabling the teams to deliver projects faster with less risk and more predictability. So that is where we are today. And where we see the future is extending the progress to the schedule recommendation. So right now it's more about Doxel's AI and any other AI in the progress tracking space, quantifying progress, converting that into a percent complete, and giving you a plan versus actual state of things, right? It is only telling you where the project is at. We definitely see the future where it is also providing recommendations based on the planning constraints or constructability of the activities on the site, providing recommendations on what is feasible based on the labor available information, using it from the labor pool that you have. So we definitely see technology moving from providing you an accurate picture of progress to a more recommendation engine, assisting, just like how ChatGPT is assisting you write better. We see construction technology assist you in making those decisions better as well.
That's amazing. Great. Awesome. Thank you so much for sharing that. We have just a question came in by one of our attendees. Kishore is asking about some specific, again, how it's been captured. So how does Doxel calculate the reinforcement quantities in slabs, beams, and things like that for progress monitoring?
Sure thing. I think it's a two-step process. Number one is, at first it uses computer vision to detect what stage of construction is it in. Is it reinforcement? Is the concrete already being poured? So once it identifies what stage is it in, it is quantifying like how much square feet of the space is in reinforcement stage, how much square feet is concrete already poured in. So that is how it is able to calculate quantities, and it is hyper accurate on the quantities aspect of it, and it is then converting that into percent complete. And the percent completes are basically going to be what are the actual quantities that are measured from the video divided by the total quantities that are expected to be installed as per the 3D model. And we are rolling that up. So we give different weightages to percent completes in reinforcement stage, different weightage to when the concrete is poured. So that is how it is able to use rules of credit to roll up to the overall for the concrete trade. What is the percent complete in this zone, in this area, or in this floor?
Great. Thank you so much. And I'm curious, Shankar, so that equipment that you will put on the head of that construction worker, how many of those are usually required for a construction site? Is it too much of an investment, or just with one camera, it's just doing the job?
So it's usually around $500 to $600 camera off the shelf. They're very easily, readily available. Typical construction site, it takes anywhere between an hour to capture 150 to 200,000 square feet. So depending on the size of the project, you might just need one of that hardware to capture. But for really large, multi-million square feet data centers, warehouse distribution facilities, you might need two or three, or chip manufacturing facilities, you might need two or three of those cameras. But they're pretty economical to purchase and pretty easy to use and scalable as well.
Fantastic. That's amazing. So, where do you see us in the future in terms of using AI? So, I really like the insight you mentioned, Shankar, about predictive analytics. Right now, we are just talking about with the AI, we are helping with real time analytics, but hopefully in the future, we move toward predictive analytics. How soon you think we will get there?
I think it's just around the corner. I would
Oh,
see that
really?
happening just around the corner. I definitely can't comment on the exact timelines because we know how we have been promised full self-driving cars a decade back, and we are still scratching at that. But yeah, it's the predictive analytics is just around the corner. I'm definitely a lot more excited about a future where, as a vice president of a construction company, I sit in my Uber, like hopefully robo taxi, and the robo taxi is driving me to work. I pull my phone up and I say, "Hey Siri, tell me what's the status on my project." And Siri tells me, "Oh, you're at 73% complete." And I say, "Okay, is it good or bad?" "Oh, you should have been at 85% as of today." "Okay, what's the delay?" "Oh, all the trades are good. Mechanical trade is lagging behind." "Okay, what's going on there?" "Oh, on floors 3 and 4, insulation stage is lagging behind." "Okay, how much production are we seeing compared to the overall project?" "On those two floors, the production is around 9,000 pounds of duct being insulated compared to 19,000 pounds of duct. So the trades are installing at a slower pace than what they could at an overall project level." "Okay, how does it look on my entire portfolio?" "On the entire portfolio, you are seeing around 21,000 pounds of duct being insulated." "Okay, thank you for that." So as a vice president of construction, I'm able to talk to my AI and see what's my status of project, what's causing a delay if there's a delay, what's the root cause of delay, is it with a specific trade, is it concentrated on a specific floor or a zone or an area, and is it production related. I saw that, but just by asking questions, I see that at a project level, it is more or less performing at a good, the trades are performing at a good rate. On a portfolio, it's 21,000 pounds of duct being insulated. On a project level, it's 19,000. So small opportunity of improvement. But on those two floors, it's 9,000. So it's less than 50% of optimal capacity. So now I know the exact question I'm going to ask the GC, and the GC already has this information. So my question is, hey, we know what's going on floors 3 and floors 4. What's causing the delay? Is it material issue? Is it labor issue? And what are you doing about it? And the GC already has an answer because every stakeholder on the project is using the same information set. So it's a collaborative approach. So that's the true state of AI that I'm excited about in the future.
Wow, that's really amazing. Like taking Chat GPT to projects, like the way we talk about, like I use Chat GPT a lot. So just when you picture that for me, just whenever I'm having a conversation with Chat GPT with the AI and just give me recommendation, even now answering the medical questions too, that better than a doctor, believe it or not. Even I give the, like yesterday I had a test result and I just took a picture, gave that to ChatGPT and tell me, I don't understand this, tell me what that means. And you cannot believe, just told me exactly what's wrong, what's going well, and all of that, all the terminologies. As you just said, I asked, okay, what's wrong, what's going on, and I cannot believe the same process can be applied in projects, that just by chatting with the AI, we can know exactly where we are behind and what's causing the issue, what are the root causes. Because right now, one of the challenges is the analysis. And I know with the AI, that help us with the insights that it's going to give us with the predictive analytics and understanding what's happening and the suggestions that it's going to give us. So you made it really exciting. And based on what we see right now at the moment, it doesn't seem to be far in the future, right?
That's true. And most importantly, it's private and it's secure. It's not sharing the data across, right? It's
Mhm.
your project's data. So we understand that working with large chip manufacturing facilities and data centers, like having the confidence that your data is secure and is limited to your usage is also of extreme importance in the construction space.
Exactly. And how about the learning? If that data is private, like with ChatGPT, because it just open, so it just learns from different things. But with the projects that you're in, like let's say you're just starting one project and you want to apply the AI, so it doesn't have any learning in advance, right? Because you're just using that for that project, or you're using a knowledge database for this project so that you just get ahead of the curve, or every time you start from scratch and then you build on as you go on. What that the learning curve would work for the AI.
So there are two kinds of learnings. So in the world of AI, or let's take this example, right? Let's say if you have a recent graduate who joins a very reputed tech company tracking construction progress. This new junior person is looking at the duct and is like, oh, this is how the duct looks. Oh, this is how it looks when it is insulated. So that's the learning aspect. It applies to AI as well, right? AI is learning how to look at a component and figure out, oh, this is what a rectangular shape means. This is how insulation looks shiny material compared to a duct that is not insulated. And that's a learning that basically is completely anonymous. There's no sensitive data involved in it. Then the other kind of learning is the learning aspect of how fast the trades are performing, how much units of work are being performing. That is private data. You don't want that data to be shared across the customers. You don't want other customers to have the insights on how fast the trades can perform, or what are the inefficiencies, efficiencies, what are the sequences. That is private to a customer. So we make sure that all the data is extremely private and secure when it comes to any planning related, progress related data. The vision aspect of it, by identifying geometries, that is like ultra that is the learning aspect that is continuously the program is learning. And we have created a construction encyclopedia over a period of 9 to 10 years, which we use to train the system. Hey, any trade, these are the 4, 5, 6, 7 stages that you have to go through in the real world. You don't see a wall system like boom, you have to first have the top and bottom track, then you have the studs installed, then the drywall, tape and mud. So we have created a construction encyclopedia that tells the software what are the stages that you need to go through. So all the AI is made up of of computer vision algorithms. You have the construction encyclopedia, and you have the insights and analytics that is private and confidential for the customers within their projects or within their portfolio of projects.
Well said. So there is some knowledge database that you feed to the machine so that it just knows and doesn't start from scratch, but at the same time
Exactly.
maintaining the privacy. Perfect. Awesome. So I think we're at the end of our conversation, and I didn't see any question coming. I just see a good comment from Greyfly.ai. So that's another great AI-based solution. So check them out. I think we had another session with them earlier this week. So check that out as well. So I'm very glad to see that a lot of AI-based solutions are coming to the market. But this discussion was really amazing. Thank you so much, Shankar, for shedding more light on the application of AI in progress tracking and how we can do things much faster and easier. I really appreciate that, and especially the video that you showed us, and the picture that you made us imagine in the future was really amazing. Thank you so very much. Just one last question for those who are interested in tapping more into Doxel or hopefully using that in their projects. What is the next step? How they can get more information from this or
Uh,
this tool? Yeah.
Sure, yeah. They can definitely check out our website, and we have a get a demo button. They can just click on and meet with our team to see the solution in action and see if there's a mutual fit, if there's a use case where Doxel can add value. Our team is definitely here to help you identify what are the capabilities of AI already in the space today that you could leverage. So definitely our team is excited to talk to you and help you in your journey.
Fantastic. And you will see the link already here, doxel.ai. So that's really simple. Just go and explore that. They have very fantastic solution that I highly recommend. I just saw a glimpse of it today. So thank you very much, Shankar. Really appreciate the time you spent from your busy schedule today to share more insights about the application of AI in especially progress tracking in construction industry. Very insightful discussion. So yeah, if anyone wants to get in touch with Shankar, LinkedIn would be the best bet, and of course, Doxel website would be there as well. Any final thoughts for the audience, Shankar, before we adjourn the session?
No, thank you so much for providing the opportunity, and it was a pleasure having a conversation. I definitely look forward to having this conversation again and talking about where we have turned around the corner and seeing those future making it present.
Exactly. Cannot wait to see where you're heading 6 months from now. Maybe we should have another conversation to see how fast you're progressing because with AI, everything is so fast. You cannot just believe your eyes anymore. So
Absolutely. Yeah.
yeah, thank you very much, Shankar. Really insightful session. I really appreciate that. For those of you who joined late or want to just go back from the beginning so you don't miss anything, the recording will be available in our LinkedIn page at Project Jewel Academy's LinkedIn page, as well as our YouTube channel. So you can go back to this conversation in the future as well. Thank you, everyone who joined us from all corners of the globe. Thanks to you, Shankar and Doxel, for sharing your insights with this amazing AI based tool. Really appreciate you. Thank you so much.
Thank you for having us.